Hello, everyone, and thanks to everyone for participating in this session and attending this session. My name is Cushman, and I'm on the faculty at UNR in Reno, and my postdoc, Tyler Refsland, and I would like to talk to you about some of our recent work, which focuses on long-term patterns in aspen performance across North America during what I think we can all agree is an unprecedented period of climate change. As I think this group is well aware, forests are a dominant feature of terrestrial ecosystems throughout the world and have a wide variety of effects on biodiversity and ecosystem processes. Unfortunately, however, many tree species are reported to be exhibiting decline, either in the form of increased mortality of established trees or reduced recruitment or some combination of the two. And numerous anthropogenic drivers have been hypothesized to be responsible for this decline, hypothesized or documented. And the big three, as we all know, are increasing temperatures, decreased precipitation, and altered disturbance regimes. Given that anthropogenic climate change is projected to intensify in the future, I think it's very reasonable to postulate that the extent, severity, and frequency of future tree declines are going to accelerate as well. So, given the importance of trees in ecological systems, and given the situation that we find ourselves in, Tyler and I feel that it's really important, and we're not alone, in developing a predictive understanding of the dynamics of tree populations. And in particular, we need to know where, when, and why tree populations are declining, where, when, and why they are increasing, and where, when, and why they are remaining stable through time. And we think that a good approach to evaluating these kinds of issues is to assess the performance of tree species across their entire geographic range, which will typically exhibit a tremendous amount of heterogeneity with respect to climate, topography, and disturbance regimes. Tree populations are unlikely to behave similarly across their entire range. And so it's really important to document the extent of this variation and then to understand why it's occurring, to get this holistic understanding of tree population dynamics. We think, as I'm sure the speakers will agree, that quaking aspen are an ideal species for studying the dynamics of tree populations. First, as Paul has touched on, they are well known for having huge effects on the ecological systems that they inhabit. Second, they have this tremendously large geographic distribution, the largest of any tree in North America, and they inhabit a wide range of biomes or habitat types. And then lastly, as Paul alluded to, there have been increasing number of reports that are suggesting that aspen, at least in parts of its range, are in decline. Pronounced adult mortality has been noted in a number of areas in the Western United States, as well as in Canada. But as Paul alluded, aspen aren't declining everywhere, and there are variable responses of aspen. And we think that this variability provides an ideal opportunity for studying the dynamics of tree populations across their range. My group is very focused on aspen, and we have a lot of different projects focusing on Aspen. My graduate student, Jacob McDonald, is leading efforts to look at patterns in and drivers of Aspen demographic rates in California and the Intermountain West, making use of existing Aspen monitoring plot network, which you can see here. And we're looking at mortality, growth, and recruitment. My graduate student, Liz Rakowski, is leading our efforts to document the role of mammalian herbivores in mediating recruitment dynamics in the Western United States. And here we're focusing on both livestock and wild ungulates. And we're making use of a series of previously established herbivore exclosures. Anyway, making some good progress there. In just a moment, you're going to be hearing from my colleague, Tom Diltz, who's going to be talking about our Aspen work in the Lake Tahoe Basin. And then lastly, my postdoc, Tyler Refsland, is leading an effort to compare the responses of quaking aspen and 2 other wide-ranging species in high latitudes, and comparing their responses to climate change and disturbance over a long period of time, and using a large plot network. But today, what Tyler and I would like to do is just give you a taste of some work that we have been doing to assess the demographic performance of mature aspen stands across their entire geographic range over the past 30 years. Due to time constraints, I won't be able to talk to you about this, but we're very interested in how stand structure and stand composition mediate the responses, the trends of aspen through time. To look at long-term trends in aspen performance, we've made use of existing forest inventory data in both Canada and the US. These plot networks have been established without regard to aspen, so we feel that they represent a fairly unbiased sample of aspen populations. To be included in our analysis, plots needed to have at least 5 living mature aspen stems, and these plot networks define mature stems as being greater than 13 centimeters dBH. We also restricted our analysis to unmanaged forests and forests that had not experienced recent disturbance and had a general stand age of 40 years or older. And here we're interested in focusing explicitly on fairly established stands. And these could be stable stands or cirral stands. They're a mixture of them in this data set. With these criteria, we selected just under 4,000 plots, which you can see in the map to the right, distributed among the 5 major biomes in which aspen occur. So you can see we have this huge sample, and each of these plots, shown by a dot in the right, were sampled between 3 and 6 times between 1985 and 2018. And the demographic metrics of interest to us, and which we calculated from the data of these networks, were percent annual mortality rate, and then the relative change in basal area of mature stems of aspen each year. And this latter variable, I just want to mention that it incorporates 3 factors. a basal area change, basal area is decreased obviously by tree mortality, and it is increased by individual growth of trees, and it's also increased by recruitment of individual aspen into the adult size class. So it's kind of a composite variable. And here's our first result, which I want to share with you. So what we're showing here is the annual percent mortality from 1985 to 2018 as a function of the different, the 5 different biomes. And what you can see just by looking in general at this relationship and what statistical analyses supported is that there's been an overall increase in annual aspen mortality through time. But there are differences among aspen in the different biomes. We see these increases being statistically significant for boreal forests, coniferous forests, and prairie parkland. We see the opposite pattern in mixed deciduous coniferous forests. And then we see a no significant pattern for deciduous forests. So annual mortality rates, by and large, are increasing in these 4,000 plots, unbiasedly chosen throughout North America. Oh, I just want to say before going on that the doubling period for mortality rates range from 11 years in coniferous forests to 33 years in boreal forests. Okay, here's the second data slide that I want to show you. What we're illustrating here is percent change in basal area per year for the same time interval and the same biomes. And what you can see for all biomes is that there's a significant overall decline. For 4 out of the 5 biomes, we see a net reduction in basal area. The one exception is the blue line for mixed forests, mixed coniferous deciduous forests. It hasn't gone below 0 yet, but it sure looks like it's on its way. So we have a net reduction of mature aspen stem basal area in plots through time in each of the biomes. Okay, so a quick summary here. We've been working with this data set of just under 4,000 plots that are distributed across the entire geographic range of aspen, and we've monitored that we're assessing and evaluating their dynamics over the past 3 decades. We feel this is a fairly unbiased assessment, and in that the plot networks were established without regard to whether or not aspen was there. We have focused on the dynamics of relatively mature stands, and what we found is increased background mortality rates in 3 of the 5 biomes, the 3 biomes that occur in more arid regions. And then we noted either decreased or stable rates in mortality in 2 biomes that occur in more mesic environments. We have seen net reduction in aspen basal area through time in these plots, with there being a declining slope in all 5 biomes, but a net reduction in 4 out of the 5 biomes that we looked at. And although I don't have time to talk to you about it, we found that these patterns that I've just mentioned persisted across multiple stand size classes and forest compositions. And this suggests that the patterns are not simply a reflection of stand development or successional processes. So just to wrap up, we think it's critical to study the dynamics of tree species across their entire geographic range, because it's very unlikely that tree populations are going to be declining everywhere, and we need to understand where, when, and why declines, increases, and stability are occurring. The likely factors driving our results, we think, are increased stress associated with climate change, increased temperatures, increased drought. And going out on a limb here, we would predict that unless recruitment of aspen into the mature size class increases substantially through time, that aspen dominance is likely to decline in a majority of environments in the coming decades. And there's a caveat there, right? It all depends on whether, not simply whether recruitment occurs, but whether those recruits are able to join the mature size class. And I think I want to echo something that Paul said, which is that I think a lot of insight about aspen is going to be gained by looking at demographic rates of populations at the edge of its range, at the drier margins of aspen's range. And with that, I will conclude. And I don't know where we are in terms of time. Will, tell me what's possible.
Well, thanks, that was great. We have time for maybe one question. There's one from Matt Schultz, who asks, have you considered replicating the analysis using FIA plots in managed forests to get at whether human intervention is able to prevent decline? Or would that introduce too much uncertainty due to high variability in management techniques?
You know, I think that would be an interesting endeavor, and I can't see, at least at this moment, any reason why we couldn't do that. I think it would be interesting to do. The reason we didn't do it in this case is because we were trying to sort of get see if we could detect a signal as to how populations of aspen were or are performing in the absence of sort of human intervention, but in the presence of human caused climate change. So our particular goal was to really see how populations are changing through time during this period of climate change. But it would be very interesting to layer in how these responses are mediated by land management activities. So I think that would be a really a valuable assessment. And the question that we would need to know is how many plots in these networks are located in areas where there is management activities going on. And we would need to check on that to see if there's a sufficient sample size to address the issues that your question focused on.
Yeah, we've got maybe 30 seconds or so. Along those lines, I'm curious, I did notice on your map not a lot of dots through the Sierra Cascades. And I was curious if that was more just because of the overall availability of study plots that you had, or that had more to do with your selection criteria, or what?
I think that, so you mean, yeah, I think that if you compare the plot locations on the right with the distribution on the left, you can see that Aspen are just much more patchily distributed in the West. I think, yeah, I don't think it was our selection criteria. I think it was, these are the FIA plots, obviously, because we're dealing with the United States. I think that's just having to do with where plots are. Actually, that's the wrong.
Right. Okay. Well, great. Thanks so much, Hall. Maybe have a couple other questions we can get to at the very end.